notice the various options that are available for bzip2. So let's bunzip and see what happens when we attempt to dump 1million.txt.bz2. Now it sees the file is there, so it doesn't overwrite it. So by default, bunzip attempts to dump to the original file. If you want to dump, let's say, the standard out, you can use the C option as we've done with gzip, so C, and that dumps the standard out. And then you can combine that with output redirection to recreate, let's say, 1million.txt3, for example, following that up with an echo of the exit status. So this sequence with the C option, just like with gunzip, works. So bunzip2, C, output redirection, 1million.txt. or text3, that is, redirects source accordingly. And as mentioned, just like with gzip, bzip2 supports decompression with the D option. So the same could have been achieved had we run bzip2 with the decompress option, sending the output to standard out and creating text4, for example. And as we compare and contrast all of these 1 million files, you'll see that the source files are all the same number of bytes as they should be. And the same applies for gzip. If we gzip with the decompress option and standard out, 1million.txt.gz, sending the output to 1million.txt, let's go with 5 this time, it behaves as expected, and now we have yet another identical file. So bzip to gzip works similarly. And similar to gzip, bzip2 has a counterpart, bzcat. This is important if you are backing up your log files via log rotation using the bzip2 compression algorithm. So to be able to bzcat, let's say for example 1million.txt.bz2 is very important, because your log files may be buried in a bzip version 2 file. So bzcat releases the content without overriding or recreating the original file. It does so on standard out. And in this case, we see that it wants to write the file, but doesn't because it exists. So let's use the send to standard out option, and it does so. So correction to that, and that is with bzip, bzip2, it looks to overwrite the file if it doesn't exist, unless we specify the -C option. So that's how it works in that particular case. So bzcat 1million.txt.bz2, and it dumps it to standard out without trying to write the file. So one's for bzip or bzip2 with the decompress option, and the other is for bzcat, getting them mixed up a bit. So bzcat dumps the standard out by default, as it should, without creating the file, which is correct. So there's no correction to the correction. So dumps original content to stout, and of course you could use a pipe to send it to something else, such as grep in search of specific records, for example. So bzcat, and let's grep the record 300,001, for example. And there's the lone record that contains 300,001 as an example. So that's bzcat, along with bunzip2 and bzip2. And as mentioned, gzip supports decompression, that is, with the -D option. Now, a third suite of tools, which may be more familiar to you if you're coming from a DOS/Windows background, are the zip and unzip pair. These are the classic compression-decompression utilities, and they allow you to compress and decompress using the zip algorithm. The syntax is slightly different. It's not as advanced or as developed as gzip and bzip2, but nonetheless it works for many intents and purposes, and often will be more compatible with your business partners whom are running, let's say, Windows with WinZip, for example. Although WinZip will read the gzip format. So to create a zip, you zip and you specify a file name such as 1million.txt.zip, and then you specify the source. So it's target first and source. So in this case, the source will be 1million.txt. The compression will be on par with gzip, not on par with bzip2. So let's go ahead and create the zip file, and it shows you that it's adding it. And now we've got 1,000,000.text.zip. Let's LSL 1,000,000 to see what's available. And notice that the size of the file is slightly bigger than its gzip counterpart. That's using zip. If you run zip with help, you'll see that it contains useful options as well, such as the ability to interrogate a particular zip archive to see what's there, and a number of other options: encryption, compress faster, compress better, just like with gzip, or to remove entries from the file. A number of options are supported. We're just glossing over the key ones. To unzip the content, use unzip 1,000,000text.zip, and let's just specify that. Then it asks if you'd like to overwrite the original file, and we'll tell it no, to skip unzipping, which is a default behavior. Again, zip and unzip are compatible with standard WinZip in Windows. So the counterpart to this is unzip 1,000,000.text.zip, and let's just note that it attempts to overwrite original file, which makes sense because when you compress, you should remove the original file anyway. And zcat in this case works just as it does with gzip. Zcat will read zip algorithm or zip compress files. So zcat 1,000,000.text.zip will do the trick, as it's compatible with both gzip as well as standard zip. And it dumps it to standard out by default. No need to specify any sort of redirection. So again, run zip with the help option, and you'll see the various options that are supported by the zip program. Number of options: testing integrity, so on and so forth. Recursion to directories. Zip also supports that, just as is the case with gzip. You can point it to a directory and it'll back it up for you, or a single file. So for example, let's see what's in temp. Temp contains 2 files, so if we zip, let's go with temp.zip, temp /, that creates the archive. And let's see what it's stored. lsltr temp.zip, we'll unzip L, which lists the contents as opposed to performing the action. And it's just backed up the directory. So let's go ahead and just include a star. And let's see what it's picked up on this time. It reflected 0 bytes. It's because the content is so small. Let's copy 1,000,000.text into temp, which will give it a little more content to work with, and then we'll zip it, and which just does the directory. Let's unzip L, temp.zip, and that's what we expected. So now let's go ahead and zip it with the asterisk to get the content within, and now you're going to see some compression ratios that are at play in this particular case. Unzip supports a number of options as well, including the list option, which we've mentioned. And as mentioned, zip supports a number of useful options as well, including but not limited to excluding following file names or specified file names using X from the zip file that's created, whether or not you like to store the symbolic links that are included, and so on, so that when it's recreated on the target file system, whether on your system or remotely, everything's recreated accordingly. Now let's look at using tar in conjunction with these tools. So 4 is to use tar. Tar creates archives. Archives ultimately are represented by a single file, but may contain one or more files and or directories. The usage of tar is as follows. We can create an archive using CVF. We specify the name of the archive just like with zip. So let's go with temp.tar, and then we specify the path. So it's target first, then source. This creates an archive without compression. Let's go ahead and try to create this, and then we'll compare and contrast with bzip2 and gzip and zip compression momentarily. So this will create the archive. Notice the archive includes temp. That's the directory entry itself. Test text, test2, and then there's enough text. And also notice that it happened quickly. That's because there was no compression. So temp.tar, let's turn on human readable, reflects the full size of the content. It's 6.6 megs because the other two files in temp are negligible. So when you use tar, you get an archive, but you don't get compression unless you specify the compression option. So let's just note another way of executing this once you've created an archive is to be able to list the contents of the archive using the L option, for example. So tar, we could do an LVF, temp.tar will enumerate the contents of the archive. Let's try this out. The L option is the key option, and it didn't actually paste, so that's tar, and that's actually L temp.tar, and it's actually not responding to it. Let's try it with the T option, which I use more frequently, and this does it, but then we need to turn on the V option to enumerate the contents, and let's see what it's showing. Let's ensure that temp.tar is intact. File temp.tar. We'll try that again. It should be TVF. That's more like it. So there it's working. And let's just see how the L option is being interpreted on this particular system. And this is an option to check the link, so it's being misinterpreted on this system, which is fine. Perhaps a slight version difference. So TVF is the option that will enumerate the contents of the tarball. So enumerates contents of tarball without extracting the tar image to the hard drive. So that's how we enumerate the contents. Now, how do we combine this with compression? CVF is still used, but then we select the type of compression. If you'd like to use gzip, use the Z option. That tells tar to pipe the content into gzip, and it's still target then source. So temp.tar, but then we'll use the common suffix that indicates that the tarball is also gz or gzip compressed, and that is with a gz suffix followed by the temp subdirectory. Now, you're not relegated to one directory. You can include multiple directories in your tarball. So let's go ahead and try this out. This will create temp.tar.gz. Takes a little time, or a little bit longer than when we didn't use compression, because compression takes time. And there's your roughly 2 megs compared to roughly 6.5 megs. Now, let's copy APVF, which will copy the entire tree that we indicate temp to temp2. Now we've got a directory named temp2. We used APVF, that is, which will preserve the permissions and archive recursively. So now we have 2 directories that we'd like to include. And to do so, just simply specify anywhere, it could be the first or the second, that both be included. And now when we tar tvf temp.tar.gz, but one caveat, now that the file is compressed, we need to turn on the Z option to pass the file through gzip or gunzip. Now it shows the content, and if we lsltrh temp star, we should see that the file temp.tar.gz, it's actually 4.1 megs, so although it contains double the content, the compression yielded a better result. Well, in fact, the zip gives us 2 megs, the gzip individually gives us 2 megs, so it's not much of a better result. It's roughly the same, 2 megs per 1 million.txt file, so there isn't a large realization. So let's just check our notes to make sure we have this described. This creates tar gzip image, and this will, the J option, create a tar bzip2 image, temp.tar.bz2 temp, as well as temp2, for example, creates tar bzip2 image. And you can specify any number of directories, and the directories and or files need not be relative to your current directory. You simply need to have permissions to access the targets in order to include them within your tar image. So let's create this image. It will achieve better compression than its gzip counterpart. Let's turn on human readable, and we see that temp.tar.bz2 is 2.3 megs as opposed to 4.1 megs, significant difference. And a tar tvjf of temp.tar.bzip2 will enumerate the contents to stand it out without extracting the file. And you may also create other types of archives with tar, such as for compress and so on. To extract, you use the X option, so let's just include that as one way in which you may run this. So you've downloaded a file from the net, let's say one of the images from one of the websites like Snort, for example, that's gzip compress. You'll tar xvf temp.tar.gz, and this extracts file recreating hierarchy. And since we have the hierarchy in place, it might be beneficial to extract it somewhere else. So for example, let's make a directory temp3. In temp3, we'll execute tar xvf, that is, temp.tar.gz, which is one level up. And as we've mentioned, to access a directory that's a level up, you use ... in this case /, since it's one level up from the current directory. This will extract the contents of temp.tar.gz in the current directory, and that hierarchy is now represented in our current directory, independent of the directories one level up, temp and temp2. Now, we're about to run another command that we didn't discuss, and that's du. Du shows disk utilization for a particular directory tree or for a hierarchy. So let's just note du shows disk utilization for directory hierarchy, which means you could run it against root, but for that case you could simply use df. So for example, du-chs, for example, or du-ch returns storage of hierarchy from current directory below. So let's see what that looks like. And that's du-ch, and it tells us rather quickly that the entire hierarchy, including temp2 and temp, totals 14 megs. If you simply wanted statistical information without a dump of the size of each of the directories stored within, just use the S option. That returns useful stats. So du-chs returns total storage sans individual items, which may be good for your reporting, for example. So du-chs, and you can apply this to any directory you want. So we're one level down in temp3. Let's du-chs from our home directory down 81 megs. So the user Linux CBT is currently using 81 megs, according to du, which operates rather quickly. So briefly, we've covered gzip, bzip2, zip unzip, as well as tar, and then we took a brief look at du as a means of summarizing storage utilization from the current directory down or recursively